And while we're going through the introduction, I guess people will start coming in. So let's go ahead and kick this off.
Absolutely. Okay. So welcome everyone. My name is Zihong. Hi. I'm the Business Development Manager at East 101, and I'll be the moderator today. Good afternoon, good morning, or good evening to you, depending on your time zone. If you find that your main screen if you find that the main screen is not showing up consistently later on, please make sure you pin the presenter or the screen with the presentation as the main screen and enable fit to frame for the best experience. We kindly request that all attendees keep their microphones and cameras off to save bandwidth. Later on, I will be turning my own camera off. So thank you very much. All right. Thank you for attending our event today. This is the 10th webinar under the East 101 webinar series in conjunction with Process Ecology. We are glad to see you here. If you like our content, please make sure to spread the word, and hope to see you at our next webinar. A brief introduction to who we are, for those of you who might be new to us. We are East 101 is an advanced process engineering and flow assurance consulting company, and we provide services to the oil and gas industry through process simulation technology in particular. We were founded in 2003 by our founder, engineer Alberto Alva-Argaez, and our offices are mainly in Kuala Lumpur / Shah Alam, where we do all our engineering and software development, as well as some of our sales and services offices overseas. Our track record includes projects which cover transient or dynamic simulation-based engineering services for design and troubleshooting, flow assurance analysis, operational assistance, in particular operator training simulations or OTS, which is an important factor we find behind safe and cost-effective operation. And also we offer process simulation training to engineers who may need a refresher or introduction to such skills and improve their capabilities. Our clients, as you can see, are quite varied. We serve oil and gas asset owners as well as EPCIC companies. If you have any inquiries, please contact myself, Zihong, or my colleague Avinash at the numbers and email addresses shown. If you'd like to take a moment to take a screenshot, please feel free to do so. So the East 101 webinar series intends to cover a wide range of domains, from upstream process design to downstream and refining, monitoring and surveillance, as well as analytics and AI. And we'll be sharing our expertise and inviting sometimes guests like today to talk about these things, to share their knowledge and get some discussion going. We intend it as a bi-weekly educational webinar, and it will usually take place on Wednesdays from 4 to 5 p.m. like today. A few housekeeping items before we actually begin. A reminder for participants to kindly stay muted. And if you have any questions, and I hope you do, please drop them in the chat box, and we will address them at the end of the session in a question and answer. If you have to step away from the webinar at any time, rest assured the recordings will be available on our webpage after the event is over. So you can revisit and go through what you missed. And now please allow me to invite our founder and principal engineer, Alberto Alva-Argaez, to introduce today's speaker. Rafael?
Thank you very much, Zihong. Firstly, I'd like to thank everyone for logging in today and taking the time to attend our seminar. I'd like to welcome an old colleague and associate of mine, Dr. Alberto Alva. I'd like to welcome him and thank him very much for agreeing to give this presentation. Alberto is logging in from Calgary, so it's 2 in the morning for him. So thanks for staying up so late, Alberto. We'll try and get you at a different, at maybe another time later for the next seminar. Let me just give like a brief introduction to Alberto. I think some of you may know him. I see there's some friends from academia who probably worked with Alberto before. Alberto is essentially a founder and managing partner with Process Ecology Incorporated. They're a Canadian, a Calgary-based company, and he's been leading the business and development and engineering software practice since 2003. So Alberto has had pretty much a key role in the development of modern web-based air emission simulation optimization management software for oil and gas. And they've been serving like over 45 oil and gas producers in Western Canada. Alberto has an MBA from the Monterey Institute of Technology and a PhD from UMIST. Alberto comes with over 25 years of experience working in various industries, operating companies, looking at optimization, the efficient use of energy, water, to develop cost-effective strategies, particularly in the reduction of greenhouse gas emissions. So prior to this, Alberto's worked in various companies, Bayer, Hyprotech and Aspentech, which is where I guess we met for the first time many years ago, and Natural Resources at Canada. So without further ado, I'm going to hand the stage over to Alberto to start with his webinar. Thank you all very much.
Yes, thank you. Thank you for the introduction, Rafael. And yes, it's my pleasure to be here today and appreciate the opportunity to share with you the work that we've been doing. Like Rafael mentioned, I mean, I'll say a few words about our company, but this presentation is going to be around evaluation of emission mitigation technologies for the oil and gas, which is one of our main activities. So let me just do something on my screen, and then I'll get going. Okay. Share. Okay, so I hope everybody is able to see my screen now with the slide. Like I was saying, the topic of today's talk is this techno-economic analysis model that we're calling TEAM, which is a software tool that's going to be assisting oil and gas companies and policymakers, as we'll see. A couple of words about this project. As you can see at the top of the slide, this has been the result of a really close public-private collaboration here in Canada, where, of course, ourselves have been involved developing the tool together with Clearstone Engineering, who is a well-known organization here also in the area of emissions mitigation, and as well with the support from the federal government of Canada. In this particular case, the Ministry, the Environment and Climate Change Canada Ministry, that has provided funding and support to develop this tool and make it a reality. So that's a little bit of the background, but let me just get going here. And a couple of things I'd like to do is maybe just a few words then about our company here, Process Ecology. Around since 2006, again, just right after, a group of people from Hyprotech, Aspentech, similar to Rafael, I guess, got together here in Calgary, Alberta, in Western Canada, and we've been working, for all this time, starting with simulation services and similar type of work. But we've done more and more in the area of environmental performance. It's still applying simulation and modeling approaches to the problems, because that's our kind of core strength, but more and more applied into these emissions management systems. So in my next slide, I'm showing the three main areas of activity of our company. Like you see in the top is emissions estimation and management. Right now, we're working with around 50 operating companies here in Western Canada, and the key service we provide is to help them ensure they are in regulatory compliance. You may be familiar or not, but the regulation currently in place in Western Canada for the oil and gas sector is very, very strict, and it requires a lot of effort and knowledge as well, particularly methane emissions. This one is one of the biggest. And so around 50 companies working with us to ensure that they're compliant with regulatory requirements. But at the same time, we help them identify reduction opportunities. As we gather all this data and generate all these reports, we use our engineering knowledge to provide opportunities or solutions to their emissions. I'm also happy to report, I guess, that Petronas Canada is one of our good clients here in this portion of the business with emissions management. Okay, so we also have a straight out process engineering and simulation group. Here is both operational support. It could be for design, for the bottlenecking, troubleshooting, but also more and more now with providing the engineering for emissions mitigation technologies. Installing vapor recovery units or that type of work. And finally, decision support software, which is really the main topic of today. But I hope that what you will see from this presentation is that these three strengths kind of come together very, very nicely in this development of team. Okay, a couple of words of background, not much, because I think this reality is very clear to all of us, really, the way the world is going. So these short-lived climate pollutants, mainly methane in our case, and greenhouse gases, so CO2, this now has become a top priority all over the world. And we can see it here in North America, where, at the CEO decision levels, a lot of the work and a lot of the projects are being driven by emission reduction. Yeah, before it was a little bit of a regulatory compliance item. Now it has become core priority for these companies. Following the news, we've heard all these announcements from politicians from all over the place. They're talking about, targets, ambitious targets, net zero, 40, 50%, including, of course, as you would know, many international corporations, oil and gas majors, other sectors, they are also committing to this large-scale emission reduction. So there's a lot of activity on this front. Now, that is kind of the context. How to do that, right? That's the immediate question. It's like, okay, sounds good. How are we going to achieve those? And in mitigation technologies, again, there's a lot of work going on. Technology developers, academia, companies, trying to come up with new ideas, with new technologies to assist in these efforts. Carbon capture and utilization, all these different names that we're getting really familiar with. But at the same time, I think it's important to note that there's, many technologies and best practices really that have been used, have been proven, and they're effective for emission mitigation in the oil and gas sector. And this is kind of the starting point for the development of this tool. Is what can be done with current technologies before the great solutions come in the future. What can be done with these current technologies? And one thing that needs to be realized, which is part of the challenge, I guess, is that yes, there's all these existing technologies, but every operator, every facility, every site really needs to evaluate which of these technologies actually make sense, given their circumstances, their constraints, their location, their type of fluids, so on and so forth. So that's kind of a picture of the challenge. And if I can describe a little bit more this problematic, this will be pretty obvious to everybody. There's typically 4 types of sources of emissions that we can find in upstream oil and gas. So of course, combustion, fuel gas combustion, useful energy, driving engines, heaters, boilers, turbines, and so on. But there's also, of course, the flaring, which is mostly a safety practice, but still combustion emissions. Probably not very useful energy, but still required. And then there's the process venting side of things, where now we have all these units like glycol dehydrators or refrigeration plants, storage tanks, other pieces of equipment that are designed to vent gas. Pneumatic devices is a classical example here in North America. Hundreds of thousands of these, controllers, level controllers, pressure controllers that are actuated with natural gas, so it's always venting directly by design. And then the last one, fugitive emissions, which is mostly unplanned. So leaks or improper seating, thief hatches, all this type of situation where vapors and greenhouse gases are escaping into the atmosphere. So those are the core items that we need to be analyzing. And then, again, out of all these sources, we know that there's quite a unique characteristic of the oil and gas is just the distribution of these sources, right? I mean, there can be, hundreds and thousands of wells in a large area, and each one may be a small contribution, but on aggregate, they're significant. So which sources are we, or should we tackle first? Yeah, what should be the priorities? And then once we come up with that answer is, okay, which technologies should I apply to these sources? There's always all these different types of options that companies and facilities need to navigate to arrive at a mitigation strategy that makes sense and makes the best use of available capital. So that's kind of framing the situation or the problematic. And like I say, this is where TEAM or that techno-economic analysis model comes into the picture. As you will see in the later parts of my presentation, I'm intending to do a live demo to show you how that tool looks like, how it works. But it's all built as a web-based application. And this tool has been designed so that it enables rigorous techno-economic evaluation of the mitigation strategies for greenhouse gas and methane for the oil and gas sector. But it does this using a detailed bottom-up inventory model, such that we can quantify co-benefits, so reduction in other emissions, what we call contaminant air contaminants, criteria air contaminants, sorry, SOx, black carbon, other benefits that may result from mitigation. And also we do this, or the tool is doing this, taking into account the constraints at the facility level, as well as local economic parameters. And again, I'll dig more into this a bit later. So with this model, you can actually do an evaluation at the site level, single site or facility level, but you can also do an aggregate for your whole company, all your assets. What's the mitigation strategy that makes sense, at that level, or just an industry segment, or you can look at regions or jurisdictions. I should mention that part of this project with the Canadian government included a mandate to support the Mexican government with a model using this tool that we would create or help them create a model of the oil and gas sector at the country level. Again, with the objective of helping their government identify optimal policy decisions for reducing emissions in that country. So like I was just alluding to, I mean, there's different types of users that could benefit from this. Of course, industry, where there's all these, discussions about, what's a good mitigation strategy, and we need to have, efficient ways to evaluate options. But like I just mentioned, governments to inform policy decisions and encourage this or that technology. We also think technology developers could benefit because once you have access to a model like this, it would be relatively easy to evaluate the penetration that your new technology could have or the impact that you could have in this particular jurisdiction. So let me just take it, this is a central concept in these mitigation evaluations. Maybe some of you are already familiar with this. It's the marginal abatement cost curves, or this MAC tool, which really these are charts, and organizations like the IEA, the International Energy Agency, they have published some of these charts, which indicate, just making reference to the charts on your left, if you like. On the on your y-axis, you have the marginal abatement cost. So dollars per ton of greenhouse gas removed, or dollars per ton of CO2 equivalent removed. And then the width of the bars is showing you for each technology, how much can you actually reduce by using that technology. So again, those are very useful. However, the way they're built, they have to rely on generic emission factors for their calculations, and also, typical configurations of facilities. So it's some kind of average representation of the industry, such that when a company or a particular facility wants to, implement or learn from these charts, then it's difficult because all these different constraints come into the picture. Are you a remote location? Are you processing sweet gas or sour gas? And what are the economics where you are located, and so on. So they become useful or difficult to apply. Whereas in TEAM, like I mentioned, it's a database model, detailed bottom-up inventory. So it's going to capture every source, every relevant source of emissions in your assets, in all your, like I said, could be country level. And then on top of that, it includes detailed engineering models. So we've done quite a bit of effort to ensure that the calculation, the estimation of emissions, and the sizing and the costing of the mitigation technologies are using detailed as possible engineering models. And then we build all this information, like I just mentioned, if we are far away from power sources, all these different considerations that have to come in this evaluation. So this tool allows us to do that. And then it provides, this mitigation, analysis of mitigation opportunities and emission reduction, all in the same integrated environment. Okay, the fact that it's a web-based tool, and I'll come back to this because in our experience, this is quite relevant. It's a continuous improvement approach. If you're involved somehow in reporting emissions to the government or shareholders or whatever, this data gathering exercise is something that happens over time, and it keeps getting better. Yeah, it's impossible to have a perfect data set and then start reporting. No, you have to start with the best you have and then slowly improve. And this distributed architecture, we think it helps because it allows multiple agents, to continue to feed into that centralized model, and then it gets improved with time. The other thing is that you now have a platform that is centralizing, all those emission factors, the details of the operating conditions, the fluid compositions, and engineering rules in one convenient location that can be accessible to many people in the organization. And then, well, I'll have to show the tool. I'll hope you agree that the graphical user interface has, allows the user to have a, pleasant experience, let's say, when doing this type of analysis. Okay, and this I'm sure, or likely will become a question later on today. The amount of data. Yeah, of course, it's if you think about, I want to build a bottom-up detailed model of all my facilities, it could sound overwhelming. However, the way we've designed this is with that situation in mind, where there's a minimum required information to get, let's say, the user started. How many facilities, what kind of facilities, where are they? Some level of activity, production accounting data, gas rates, oil rates, maybe water rates, condensates, that high level information. And then with that, you can get started. What TEAM has is, a whole range of default values, engineering rules to help you create a model that, although might not be, very accurate in that first pass, is going to give you a very good starting point to start screening opportunities, within your asset base. Yeah, so that's what we call the auto-configure functions. Again, just to give you a quick example, if we have an oil battery, let's say, that we know. All we know is the production rate. We know the type of fluid. Is it heavy oil? Is it conventional light oil? Is it sour gas? With this configuration, then we apply engineering design rules to determine, okay, the typical configuration of this battery would be X number of inlet separators, followed by potentially treaters, heated treaters if it's heavy viscous oil. And then there's going to have, if it's recovering the gas, then we'll need dehydration, maybe a sweetening plant. So you see, it's all this kind of logic around engineering rules that would allow you to configure the model easily. Okay, talking about model configuration, I'll just say a few words about this. The way you set this model up is, like I mentioned first, you have to declare all your facilities. This is a partial list of the facilities that can be used for building an oil and gas model. Like I said before, it could be a single, gas plant or something that you want to model, or it could be the whole country, which is typically where the power of the tool comes in, but it's still useful. So you add all your facilities, and I'll show you there's ways to do this in bulk, of course. You cannot, do this one at a time in general. So you add all your facilities, and then again, whether you're using auto-configure or whether you actually have the information of what equipment pieces, it's almost like a flow sheet, yeah? Because each one of these pieces of equipment will have one or more emission sources that the tool needs to consider. So just to give you an example in the next slide, when we're adding a reciprocating compressor, there's tons of these units in the sector, of course. These units now suddenly have several emission sources implied in them. Of course, the most direct one is fuel combustion in the engine, driving that compressor. What's your fuel gas composition and what's the duty, and then so on and so forth. Then you can estimate the emissions, CO2 emissions, and probably uncombusted methane in some of these machines, and do that estimation, how much emissions from this compressor. But there's other elements. So now, this issue of venting from the packing, which is understood to be a continuous source, and it's by design on these machines. But again, how much of that is contributing? And now we're talking about venting natural gas. So it's methane emissions, higher global warming potential, all this situation. So we need to take into account for these packing vents. And in addition to that, pneumatic devices. Do we have controllers that are pneumatic, gas pneumatic controllers, active in this package? How many? Where are they? What kind? And fugitives. This one is a little harder one. I mean, of course, if you're doing surveys, a group of people going to the field with their cameras, taking notes and quantifying, you may have good information on some facilities, but in general, this information is harder to get and it changes with time. So we use more a statistical approach, number of components and typical emission factors to estimate fugitives. And all that happens just in one of the pieces of equipment, in this case, the compressor. Then the tool, once you've loaded everything, again, it's gonna help you automatically generate your marginal abatement cost curves for all these different technologies. And then it will allow you, it's a flexible system now, because you can start, playing with different variables. If you impose the budget constraint on this system, how does that, which technologies should be selected? How much can I reduce my emissions given a budget? Or how much is going to cost me if I have this target reduction? So in any way, in other words, it just gives you that flexibility to start exploring different scenarios. This is the typical workflow using the tool. Again, there's going to be this data gathering and review. I mean, I think the boxes are same size, but this could be a significant effort depending on how your data systems are shape is. Then with this, again, you load the system to configure facilities, emission sources, this activity data, like I mentioned, production rates, and so on. And this, is the results section of the tool, where even before you go into mitigation, just having an inventory of your sources and your emissions profiles, we think it's already valuable. This information can be used for reporting, for other things. But again, we don't stop there. Team continues and applies the mitigation technologies accordingly to the appropriate sources so that you can do your MAC analysis and ideally come up with an optimal mitigation strategy for your particular facility or company or region or whatever level of analysis you're doing. Results, like I said, you can take a look at the emissions of particular equipment or at the facility level or at the system level. That's kind of the granularity of the model, both on emission profiles and also on mitigation strategies. In this case, you can see what is the MAC curve, like the one in the middle, that is best suited for a particular facility. And then you can actually drive or dig deeper into that specific technology that seems promising, and then have access to all the information like cash flows, capex, opex, emission reduction, all this economic information that's required for the evaluation. Okay, at this point, I think I like to maybe switch over to take a look at the tool itself, maybe go through a brief live demo. Does that sound okay? Or do we want to, I think questions were at the very end, right, Xiong?
Yes, Alberto. Please, if you would like to move into the demo, I think that's fine.
Okay.
I'll address questions at the end.
Okay, great. So let me just go here. And what you see now on my screen, it's a browser. I'm just using the Chrome browser. And here is the URL, this team emissions. Here's where we have the landing page. And again, accessing this tool would just require your kind of secure credentials to go in there. So I'm just going to go in there as myself, log in. And then this is kind of the first view that you get. So team, right now it can hold different projects. We're calling each one of these cards a project, and it can hold it in the server memory. There's different configurations. It can be saved locally, but this version saves in the server. So each project, the user can start creating different types of projects here and there, and each project can have multiple cases. Again, it's just some kind of structure such that if I want to compare between cases, I should go into one project, create multiple cases, and then I can easily compare them there. And again, there is just providing some flexibility for the user how to use it. So like you will see here, lots of Mexico showing all over the place. And this is due to the fact that part of the mandate with the government of Canada was, as part of a bilateral agreement for technical assistance. This project was to develop the tool and deliver, the models for the different, in fact, the different sectors in Mexico. But today we're talking about the oil and gas. So let me just select that case. And okay, so what you will see here is the oil and gas sector in Mexico. So clearly, very highly concentrated, along the Gulf of Mexico, with just some of the refineries inland. What you see here in this top menu is just the different items that I mentioned that you need to build your models, all the facility types, wells, onshore, offshore, gas plants, compressor stations, oil batteries, and so on and so forth. So this is the model that has already been configured. I'll bring your attention here to this menu on the left where I have the current case. When I click on it, you see I have my workflow that I described before. So first is all this configuration in this blue icon. And there's several different tools inside that configuration that's going to help us with the setup, including using spreadsheets or importing files to create that setup. Then you execute the model, and then there's some mass balance for QA QC for performing checks on your configuration. But then you see the air emissions dashboard, which was the first set of results, and then finally the mitigation strategies. So if I was to click on this air emissions dashboard, let me just go there now. And again, this takes a couple of seconds to solve. There's part of the, I guess, challenge in building a web-based tool and trying to solve these large-scale models with engineering, with some good level of engineering detail. We've managed to bring it to a reasonable performance. So what you see here is now the emissions profile of Mexico. And again, we have validated these numbers with some of their official reports, and it's a pretty close match. So you will see here greenhouse gas CO2 equivalents close to 39 million tons per year, and you can see here the split. This is oil refineries, stations, gas plants, gathering stations, offshore platforms, and so on. So by facility type, you can do that quick analysis. You can also come here and take a look in a different way. By emission type, what I mean is fuel gas combustion, pneumatic venting, flaring, vented direct vent gas, fugitives. And here specifically for methane. Like I say, there's been quite a bit of attention paid on methane emissions reductions. And what you will see is the current set of mitigation technologies that it's available in this tool. It's very, very much tailored toward methane reduction, right? And not so much CO2 from combustion, as that's a little different problem to address. But you'll see it's also reporting values from black carbon, typically, usually mostly from flaring, and then criteria air contaminants for the whole system. So CO, NOx, VOCs, and PMs, and so on. So you get these results out of this tool. What you can see in these cards is that the model currently has just got over 7,000 facilities with over 9,000 emission sources that have been quantified using, again, detailed engineering models or in some cases, emission factors like fugitive emissions. And the table below here will give you, the highest emitters. It's just kind of your top 10, which in this case is mostly the refineries in Mexico and some of the larger offshore installations that they have there. So again, that was the step where we look at the emissions profile. And then now what I'm going to go, and I'm just going to click here on this mitigation strategies portion of it's another dashboard, again, just following that workflow. What this dashboard is doing right now is based on those emissions profiles that we saw before. And remember, it's a bottom-up approach. So at this point, we know, for instance, for each compressor in your database, we know what's the volume, the composition, and the pressure, for instance, of the gas that is being vented. So now what this tool is going to do is going to look and pick all these mitigation technologies, apply them to each one of the sources in the database, and come up with these aggregate results. So now it's, rendered this map chart, which again, it's at, right now we're saying it's at the level of the country, and where we can, fairly quickly identify, okay, because venting was a significant number in Mexico, it looks like given their characteristics, using that gas to generate electricity would be a very interesting option with a, quite a negative abatement cost, a marginal abatement cost, which in other words means it's an economic, it's a positive, good economic project that could be done. Or vapor recovery unit installations. Again, then there's a set of different technology options. Like I said, the width of these bars will tell you how many tons of CO2 you can reduce using each one of these technologies. What you will see here is that the tool, the calculation engine, went over all the database and estimated or evaluated just over 22,000 projects to come up with these results. In the table below, again, it's just a ranking by project with the largest mitigation potential. Notice it's not the best marginal abatement cost. It's just which ones would give you the biggest reductions, even if they may be expensive or not. But here I can see several negative numbers, which is all what you want to see. And then again, installing different technologies. These are some of the big offshore platforms that Mexico operates. So anyhow, this is kind of the the workflow, very, very high level. To show you a little bit more detail, let me just do something. I'm gonna go back to my configuration, to my map, where I'm displaying all these different facilities. And I'm gonna apply this filter icon just here. So I'm gonna take a look at a subset of my facilities. You see here, all of them are selected. So I'm just gonna take them all out and only look at my gas plants. It's something that I think it's important to notice, that when I apply a filter at the level of the tool, of the configuration, then it affects everything else. So if I was to go back to the air emissions dashboard, now you will see, okay, now it's reporting emissions only about 9 facilities. So out of the 7,000, mostly of them are wells. But in this case, there's 9 gas processing facilities, and then it's reporting the numbers based on what I picked the filter. So again, the tool becomes flexible, and it allows you to explore your different combinations of facilities and your analysis. I mean, of course, here by facility type, 2.8 million tons of CO2 equivalent, not very interesting. But I can still review by type of emission. Fuel gas, flaring is significant in Mexico, venting as well. Okay, so now that I'm just kind of narrowed down into the gas processing system, you see here are my top 10 emitters. And what I'm going to do is I'm just going to take a little dive into one of these. So you see I've got these icons that if I click on it, then I kind of take this dive into that particular facility, which in this case is this Ciudad Pemex facility, where now I can see the summary for that particular gas plant. So how much is venting, methane, greenhouse gas, how much is being flared at this facility, how much emissions due to combustion, due to fugitives, and due to pneumatic devices. So here's a nice summary just for that facility. The other thing I'll show you when I'm at this level, I mean, I still can navigate my 3 steps: configuration, air emissions, and mitigation. So instead of going up and down in this what I call the vertical navigation, we have this horizontal navigation. So let me just click on this one, and you see it takes me to configuration. So what I see, this is how, in this case, a gas plant, this is how a gas plant is configured in TEAM. Some general administrative information, where it's located, so on and so forth. Activity levels, so oil condensate, gas throughput, water, some characteristics of the flaring, what type of gas is processing, is it processing liquids, all this key information about the facility. And you will notice some information here. Again, this, I guess, still a little bit of a work in progress. Some of the mitigation technologies will be affected heavily, like we said, by local considerations. So some of the key information is how far are you from a power source, from transmission lines. You see in the analysis initially, we saw, looks like power generation is a great opportunity. But if you have to build kilometers of transmission line, then that mitigation technology goes off. It's going to be too expensive to do that. Similarly, how far are you from qualified labor? This notion of performing leak detection and repair, surveys every 3-4 months, 3-4 times a year. that's the distance and the availability of this qualified labor will impact. Yeah. So anyway, all these different parameters are taken into account. And what I have down here is the configuration. Remember, there was the facility and then the equipment, which includes the sources of emissions. So I have, is dealing with sour gas. So there's a bunch of amine plants, sweetening. There's several centrifugal compressors operating there. A couple of fractionation units, refrigeration plants to extract liquids, sulfur recovery, and storage tanks. So these are my kind of key equipment in terms of emission sources. If let me take a look here at this refrigeration unit, and now I'm going to go even deeper into the bottom-up with detailed model. So now I have here a refrigeration plant where now I know how much gas is processing. I know the gas composition, and you see this level of detail of information. What's the temperature and pressure of the inlet, temperature and pressure of the low temperature separator, the glycol circulation rate, the ethylene glycol rate, and what type of pump is using, is it venting or flaring? All that configuration of that particular equipment then determines the emission calculation for methane venting, for instance. Again, you see all this, and we borrowed this from other software tools, but the team software comes with a ton of default values. Again, it's going to be difficult to get to this level of detail quickly, before you can do an analysis for many facilities. So it comes with a ton of sound information based on good engineering practice for these types of facilities. And what I like to notice, you see, with this information, you would typically be able to run a simulation model, for instance, a symmetry model, a HYSYS model, and then come up with a venting. And then we've done that many times for our own engineering practice. What we're doing here, though, is to use, again, those same input parameters, but we're using a neural network model. So instead of having to run all these, iterative calculations for distillation, we're using some machine learning algorithms, just run, the simulation hundreds of thousands of times, and we are very aware of the operating envelope of these units. So we can, quote, kind of enclose that envelope clearly, and then use those models to predict the methane venting from these facilities. We've done a bunch of comparisons, and it's a pretty good approach. And in addition to that, notice this. This is the typical process information you would get, and you would get venting volumes. You may even get, duties for heaters and reboilers and derived fuel combustion. But we also need to carry fugitive emissions. So how many connectors, valves, pump seals are present in this plant? Are you using pneumatics, gas-driven pneumatics? Are they high bleed, low bleed? You see all this additional detail that is typically not kind of considered in process modeling, has to be brought into bear in this analysis. So then, if I navigate again, I can see the detail of this particular piece of equipment, of this plant, the refrigeration plant, and again, it just aggregates up like you saw before. Okay, and then, just continuing to navigate this. So we saw this is the configuration. This is the summary of emissions for the facility. And now what I see here is the MAC chart for this facility. So you see, because I have this 0 distance, it's still telling me, okay, look, if you have transmission lines right there out of the plant, of course, take that vented gas, burn it, generate power. And, other options are interesting, wet seal degassing for your compressors, replacing your high bleed instruments, VRU installation, vapor recovery unit. And I'm just gonna maybe bring your attention here. These are the technologies that were selected for this facility based on the sources, based on the type of source present. So if I dig deeper into the VRU, excuse me, you'll see here is where the economics come into more detail. What is the capex? What we're doing here is, as I said before, at this gas plant, now we know the volumes, we know the compositions of gas that is venting. So with some assumptions around discharge pressures, we can then size, how big the compressor needs to be, and based on cost correlations, determine, what is the capex, what is the opex, is there, gas that's going to be recovered that you can sell, is there a carbon tax? All these different parameters come into this cash flow estimation that finally would give you your marginal abatement cost. So that's the level of detail. Again, I'm kind of started pretty high level, then went, took a deep dive. Sorry, I'm just gonna, one thing before I open it for questions. Let me just show you one more thing here in the configuration, in the settings, case settings, mitigation. Of course, this is important piece of information. This is the set of mitigation technologies that are currently implemented in TEAM. Now, again, it doesn't mean that it's a comprehensive list. It's relatively easy to continue adding more options. So you see here's the VRU that I was talking about before, where now the user has this opportunity to specify how do you want to implement this technology. And something else that I noticed that pretty much everything is exposed as user input. So if you want to change the type of compressor, you can do that here. If you have a better correlation for cost calculation, of this type, then you can update your parameters here. So you see is a leak detection and repair, vapor recovery unit, wet seal degassing for centrifugal compressors, replacing gas pumps, rod packing replacement for reciprocating compressors, flare, which probably won't be, very acceptable mitigation technology soon, but it still works, right? If you're venting methane, it's still a better option. And like you see here, there's a few other mitigation technologies. So with that, I think I'm gonna probably leave it there. Let me just go back to my presentation. And then of course, please let us know if there's any questions. I have not been able to follow the chat, but I'm sure I'll hear about it.
Thank you very much, Alberto, for a very interesting presentation, and as well as the generous sharing of all the tips and tricks and the behind the scenes review of the technology. Certainly, the pressure is building to make our energy sources greener, right? And we do, for the moment, know only of one habitable planet, and it's definitely interesting to us to help reduce emissions and keep us alive a bit longer. So far, we don't have any questions, but I did have my own question, if it's okay to ask.
Yeah, sure. Go ahead, Xiong.
Thank you. So from my own experience, the adoption of new technology, such as TEAM, this kind of software, often faces some resistance from at various levels. And I was wondering whether you had any experiences to share with regards to what that process was for the collaboration with Mexico, and perhaps if you have any interesting stories from users who tried it and had their whole worldview perhaps changed, and what that might have been like.
Yeah, no, that's a great question, and I totally agree. I mean, there's going to be resistance. There's established ways of doing this analysis. In the case of the government of Mexico, again, I want to make a distinction. These were the policy makers, not because Pemex, the oil company, is very close with the government, but we did not work with the actual operating entity. It was more for the policy decision people in government. So again, there, I think the key challenge usually, the first thing that people say is, oh, okay, no, this sounds great, but where am I going to get the data? Yeah, and that's why we made such a strong point in saying, look, in our experience, you don't need perfect data to start. And we've seen this in other emissions reporting in Western Canada. There's one particular regulation related to benzene emissions from dehydration. And it requires a lot of data. You need, again, fluid compositions, pressures, temperatures, circulation rates, and so on. And we've been doing that report for the last, I'm going to say, good 15 years. Yeah, for maybe around 40 companies. And every year it gets better. Yeah. So there's no chance of starting with the perfect data set, like I said. You start with the best information you have, but then the key is to bring and apply your best engineering knowledge to fill in those gaps, right, in a reasonable way, and then you're off to a good start. So I think that's been usually the biggest, at least initial roadblock. Is like, oh, look, we don't have this data, and as you know, any model, bad data in, bad data out. But we're saying, look, there's ways to control that and start getting valuable results quickly. So I don't know. That's yeah.
You're on mute, Zihong.
Sorry. Thank you, Rafael. So I hear you, Alberto. It makes a lot of sense, particularly with the amount of work that has been already put in with team and a neural network. It does make sense that what you're saying, where with a limited data set, there's already enough experience in a way loaded up into the software to make some preliminary steps, and then once the ball gets rolling, momentum kind of takes over. Is that right?
Yeah, no, for sure. And it's like any other analysis. I mean, if you, during a preliminary review, you identify some options that are not interesting at all, then that's already valuable, because then you kind of concentrate your efforts in those that appear more promising. So again, it's just this, getting closer and closer to the optimal successive approximation, I guess, or something like that.
Speaking of promising technologies, something that occurred to me is that team seems really, really useful for situations where you have a limited budget or a limited time to act on certain things. For example, sort of getting to a zero emissions target by a certain date. So team, it seems to me that team is designed to cut through potential analysis paralysis, because there's a lot of options for mitigation technologies and evaluating different sources. So I noticed that for at least for the case study that you showed, there seems to be quite a large amount of value immediately that can be recovered just by looking at the first mitigation option that's evaluated. Is that a common thing, or is it really going to depend on the individual?
Yeah, no, and that's the whole premise around team, is that it really depends on their jurisdiction, on the operator, on their configurations. Like we in some of these facilities, it was a little bit surprising to us to see that there was so much venting going on, relative to what we've seen in Canada, for instance. Then in the other configuration, or in the configuration of the facilities, we get to understand that in Mexico, they don't use glycol dehydration units to dry the gas. They pretty much aggregate everything in large central facilities and use molecular sieves for dehydration. So this changes the profile. And I think it's going to be the case, in every different jurisdiction and different operators. So that's why it's so important to really take into account what is the reality of your own circumstance, of your own facilities, to determine this mitigation strategy. And maybe I didn't mention that, but again, something else that needs to be customized, I guess, once you move this tool into a different jurisdiction, is the cost correlation parameters, because those are real for Mexico, but I mean, I don't know if they would apply just as well in Southeastern Asia or even in Canada. Those parameters have to be carefully reviewed if an exercise is going to be done there.
I see. We have a question from our audience, from Mr. or I'm not sure, Sven Riebe, who asked...
Sven Riebe.
Sven Riebe. Rafael, this is somebody you know?
He's an old buddy.
Old buddy. Thank you for attending the webinar, Sven. And they ask which countries use TEAM currently, I suppose. In which countries is TEAM used?
Good question. Right now, the only full case study we have is with Mexico, and allow me to say that this project got started at the end of 2019. So yeah, it's maybe a year and a half ago, and I'm talking about writing the first line of code to the data gathering and so on. So right now, there's been a few applications here in Alberta. Not at the country level, but at the company level in Western Canada. And we're just under discussions with Colombia as well. But that's the extent of the experience so far.
Thank you, Alberto. We have another question coming from Mr. Kevin Chu, who says, hi, Alberto, thanks for the presentation. And they ask, you mentioned that we do not need perfect data to start. So what are the challenges that you faced or that might come up when you were trying to convince the end user that the result generated from TEAM is actually convincing or feasible? Alberto, you're on mute. Sorry.
Yeah, no, sorry. I started thinking. It's a very good question. You know what? I think our arguments in this happens, like I say, in different reporting, frameworks here in Canada, was that as long as your engineering assumptions are sound, then your conclusions are likely to be, in the right direction. Again, you cannot, claim accuracy in that first pass, but it's going to give you a very good view as long as your assumptions are sound. And I think that's the area where we can, based on our experience in groups like Clearstone Engineering and Environment Canada, we can come together and say, okay, look, this is typically what's going to happen, or these are, typical operating envelopes in the industry. And the reality is that, oil and gas, it's oil and gas everywhere. And, the behavior of the fluids, the venting from tanks, all that, is fairly well understood. So I guess if we bring, sound assumptions, I think we can, convince people that these results are meaningful. And then, there's going to be different strategies depending on what quality of data may be available. I don't know. I hope that's a good answer to that question.
I see. So it depends on the engineering principles that are guiding the data that is put in, and the
Yeah.
considerations that are known, and using that information wisely.
And you know what? Let me just add something more, because you know, we had an experience, again, not at the country level, but with one of our clients here in Canada, where they saw the mitigation you know, challenge coming, and their strategy was to go by source type. So to explain, they decided that first of all they were going to go to all their facilities and replace pneumatic devices, high bleed to low bleed or no bleed, you know, controllers. And once they finish all that process, which was, like I said, I mean, hundreds of thousands of devices out there, then they would move on and start looking at glycol dehydration plants and start optimizing that. So they were following this, I don't know, order, in, if you like, logical approach. But however, when you come in with a model like this, and you can see clearly that it's not in your best interest to just go across the board with the same strategy, flat, you know, across all facilities, but that your capital would be better spent saying, you know what, in the Northeast region, take a look at dehydration. Yes, in this other region, replace pneumatics. You know, in the Northwest, maybe, you know, attack your tanks. So it becomes a lot more detailed, or how can I say, more precise strategy to reduce your emissions and get the most of, you know, reduction out of your investment. So I think when people start seeing these, you know, indications that things could be much better in terms of how you're spending capital, then I think they pay more attention.
Right, I see. So for them, they took the blanket approach, which may not yield the maximum bang for the buck, because there might be other aspects that could yield much better value for different facilities, right?
That's right. That's right. But I mean, at some point, if you don't have a tool, a modeling system like this that would allow you to take a look at the whole, you know,
It's
set of
difficult.
assets,
Mhm.
it is very difficult, if not impossible, let's say, to gain this insight. You know, that's yeah.
Thank you, Alberto. We have a couple more questions coming in now. First one from Avinash. He says, "Hi Alberto, I'd like to understand how the end users utilize Team. Is there any option to have it integrated with live data sources for emission monitoring, or do the users have to update the data manually when they are performing a study, or constructing or updating some equipment data?"
Yeah, no, great question. I mean, the way Team has been used so far, it's been, you know, let's call it manual updates. What that means, let me just see if I can go back here to my, if I'm still sharing. Can you see my screen again with Team?
Yep.
Okay. So here in the configuration portion, you see we have these options to import a file. Again, there's a JSON schema, let's say, that would allow you to pull a bunch of data, you know, in bulk. Now, this is not yet, you know, real time, or you know, automation in terms of pulling data in. However, we're working with a few clients, and you know, what we're finding is that the data that Team needs is usually in different places. So we're providing APIs to, for instance, start pulling gas compositions from a specific system, and then feed our tools. Then there's another API, another service that would allow to import, you know, operating hours for these different facilities. So it's, I think it's work in progress, and we're learning as we go, because every company seems to have, you know, slightly different data management strategies. So, but again, I think what I'm saying is there's possibility to improve the automation. Right now, we rely on these files, or even, kind of this copy paste. We implemented these spreadsheets directly into the tool, where users can copy paste data also to do bulk upload.
Okay, thank you, Alberto.
But yes, we would love to get there.
Yep. Okay, thank you, Alberto. A question coming in from Professor Dominic Fu, who notes that the MACC is similar to carbon pinch analysis. So he asks, do you think it's worth it to develop an interface for carbon pinch within team, I suppose?
Yes, thank you, Dominic. Good to hear from you. It's been a long time. But yeah, I mean, you know what? The carbon pinch analysis would be another result that could be, obtained from all this wealth of data. So I don't see why we wouldn't do that. Again, I think right now what we're trying to do is to, present this to the market that may not be so familiar with carbon pinch. They will be familiar with MAC for sure. So maybe slowly keep adding, more utilities and more value as we go. But again, first of all, we have to prove or demonstrate how the value of this tool. But yeah, no, it's a good suggestion, Dominic. Thanks.
Thank you, Alberto, and thank you, Professor Dominic, for the interesting idea. So far, we have no more questions, but I am curious, going off of the concept that Avinash raised of integrating with live data. I noticed that a lot of inputs to team are things that are inherent in the configuration of the plant. For example, number of valves and the type of equipment being used, the bleed, high bleed, low bleed, things like that. So I was wondering how much resolution would teams actually require to make a reasonable analysis of the emissions risk, because the focus, in my understanding, is to mitigate that risk of emission and using various technologies. Is that correct? So then what is the resolution of the kind of data that you need to key in?
Yeah, and I think that's maybe related to what we were discussing earlier, that, I mean, of course, the more accurate your data, the better your outputs. That I guess that is the case in every model. Now, for again, high-level directional decisions, for instance, the number of, valves or the number of pneumatic devices. I think if you rely on the, average values that are already implemented in team, that come from studies, that have been done, for instance, by Clearstone Engineering, to determine the number of components by type of plant. Again, that's not going to be totally accurate, but it's going to give you a very good indication where you need to be looking. But the better the data,
What about resolution from a time series perspective? Because if I've arrived at a number of valves for my plant, that's typically not going to change in the course of perhaps a few months, perhaps a year. But
right.
Integrating with live data, for example, is it hourly that these things would change and have an impact, or are you looking at a time scale of more?
Yeah, no, I see. That's an excellent question. The way TIM is designed, and the current version, I think it's the time scales are almost like yearly averages, because we were talking about what's your inventory of emissions for 2017, 2018, 2019. So that's kind of the time scale that TIM currently understands better. However, there's lots of opportunities, if we get to that level of, linking to live data, and then, we get further granularity.
So event.
Yeah, exactly. So there's lots of opportunities to make improvements there. But we want to, like I say, take, one step at a time. And although we have these big ideas as to how this could be used, we want to start proving value every step of the way.
Absolutely. Thank you. Okay, time now is 5:15. I suppose we will take another 5 minutes with the questions. If anybody is typing anything in the chat, we are waiting for you. And if not, thank you so much to everybody who has stayed up till now. I hope the talk has been useful. The questions have been pertinent. If not, if later on you find that you have further questions to ask, please reach out to the email on the screen, sales@east101.com. We will definitely be there to answer to the best of our ability. I hope this has been a good session for all the attendees. Yeah. Thank you.
Yep. Thank you. Thank you very much.
I'd like to thank everyone for logging in, and thank you very much to Alberto. And we certainly hope that we've managed to get people thinking about emissions management, and hopefully we've drummed up some interest over here, so we can actually start taking a look at some problems for management and mitigation. So thank you very much for the presentation, and for staying up so late. Hope you managed to get some rest after this. And for all the attendees, again, thank you very much. Everyone, please stay safe, stay healthy. Take care.
Thank you.
Okay, thank you.